In an aqueous solution of a weak acid, an equilibrium is established between the undissociated molecules Ha and the ions H+ and A-. Click the Simplified button if you wish to view the simplified version of the equation. The degree of dissociation of an acid depends on the position of equilibrium between the undissociated molecules and the ions. The further to the left it lies, the weaker the acid is. We can get a measure of the position of the equilibrium by writing an equilibrium constant for the reaction. Click the Kc button. The concentration of water is largely unchanged and is considered a constant. Click the Rearrange button. The product of Kc and the concentration of H2O is a constant and is called the acid dissociation constant Ka. Ka is a constant value at a fixed temperature for a weak acid. Click the Simplified button if you wish to view the simplified version of the expression. What happens to the value of Ka when the concentration of H+ is decreased? Answer: Ka decreases when the concentration of H+ is decreased. The weaker the acid, the smaller is the value of Ka. We can calculate the concentration of H+ ion and hence the pH of an aqueous solution of a weak acid at equilibrium given the initial concentration of the acid and its Ka value. Select Example 1 from the drop-down menu. Methanoic acid is a weak monobasic acid. Click Next to find out how to calculate the pH of 0.1 mole per decimeter cube of methanoic acid solution. Click the Equation button. Click the Initial Concentration button. Assume X mole of H+ is formed. Click the Equilibrium Concentration button. Click the Ka button. Drag and drop the correct formula from the equation into each of the boxes shown to get the expression for Ka. Now, click the Ka button to view its given value. Click the Rearrange button. The value of X and thus the concentration of H+ is obtained. Click the Concentration of H+ button. The pH of the solution is 2.4. Click the Summary of Steps button to help you recall the steps involved. Select Example 2 from the drop-down menu. The pH of 0.5 mole per cubic decimeter of HA is 3.4. Let us now work out the dissociation constant of the acid. Let the concentration of H plus ion at equilibrium be x mole per cubic decimeter. Click the equilibrium concentration in mole per cubic decimeter. Click the pH button. Click the concentration of H plus button. Click the Ka button. Drag and drop the appropriate formula from the equation into each of the boxes. Now, drag the correct equilibrium concentration values into the empty boxes. Click X to substitute it with the value obtained earlier. Summary: an equilibrium is established between the molecules and ions of a weak acid, HA, when it is dissolved in water. HAAQ plus H2OL reversible, H3O plus AQ plus A minus AQ, or HAAQ reversible H plus AQ plus A minus AQ. The acid dissociation constant of an acid HA is given as Ka is equal to the concentration of H3O plus times concentration of A minus upon the concentration of HA, or Ka is equal to the concentration of H plus times the concentration of A minus upon the concentration of HA. The weaker the acid, the smaller the value of Ka. The pH of a solution of a weak acid can be calculated using its initial concentration and Ka value.